One. Hello, everybody. I'm Martin. I work for a company called OpenSensors, where I run the engineering team. This is my first DevOps conference. Thank you for having me. I'm kind of coming from this from very much like the dev side of the fence, if there is a fence, I don't know. But in my last kind of 5 or 6 years, I spent a lot of time in working in small projects and small teams. And I've kind of gravitated a bit to doing the kind of DevOpsy stuff, mainly because, I don't know, the other team members maybe thought I could speak to the Linux VMs, so they kind of gave me those tasks. But I think it's great with conference like this, and there's been a lot of good talks to kind of raise the discussion and the importance of operations a bit. And I think a lot of the dev attitudes needs to mature a bit, so to really highlight the importance of ops. So that's great. Thank you everybody for being part of that. So which brings me to this talk, which is very much not very like philosophical or high level, I'm afraid. It's much more like gutter realism, tales from the trenches. It's basically 2 parts. The first part, I'll try to speak a little bit about, architecturally or the problems that might be different for an IoT service compared to your standard kind of web service, if we use that as a, the comparison. And the second bit is more, some stuff that we actually did during the last 2 years, maybe. Some of the problems we have and how we try to apply operations to running our service. So a little bit more about me. Like I said, I'm primarily a developer, kind of messing a bit about in the DevOps space. I've been doing it for about 2 decades. Lost a few years to management, but I'm kind of back on track now. Full stack, I've heard a lot of times. I mean, I don't know how useful that term is, but like I said, I mostly work in small company or small projects. So a typical day will involve, Chef, database migrations, cloud formation, fixing the backends, all the way up to the CSS. So everything. That's kind of what I do. And in the IoT space itself, I've been doing that roughly 2 years. First, a company called Sively that you might have heard of, and now OpenSensors. So what does OpenSensors do? So it is a cloud-based platform, like a SaaS, I guess you would call it. So we provide a real-time message broker, kind of architected a bit for these things in mind. So talking the protocols that the things are talking and supporting the kind of hierarchical models that typically things exchange information. There's an API, of course, where you can manage your devices and stuff, and also pull down data that your sensors has published, like historical data, also real-time data. And the big thing where the actual value comes is the analytics side, right? So there's one thing of message brokering and APIs, but the whole point of it is to analyze the data and kind of hopefully bring some value to it. So that's the kind of the third piece of the story, bringing tools to kind of extract some meaning from all this data. The other thing we try to do is kind of push for open data. And what does that mean then? Well, imagine now, I'm sure you've seen numbers on how many IoT devices there will be in the world by, 2000 and trillions of them. And you can imagine a world where it would be better if a lot of the data collected by all these sensors was open, right? So we believe that idea if everybody, when I say everybody, like companies, communities, governments, and even individuals, if they come together and kind of open their data, everybody benefits, right? It would be quite silly if all these sensors were kind of siloed up and nobody can see any other's data. And the idea here was kind of similar to kind of the web or open source, that let's open the data and let everybody benefit. So we're trying to provide a platform where these communities can come together and explore and find open data. And for companies, maybe provide a way for them to kind of mix and match, right? So I have my secret sensors collecting some data that I don't want to open, but actually it's quite interesting if I can kind of mix and match, right? You pull in some open data in this analysis and give me a better understanding of what's going on for my particular problem. So that's what we're trying to do. OpenSensors.io is the site, looks like that. Okay, so that was introductions. Now let's look a little bit on, like I said, the kind of architecture or the architectural challenges or operation challenges that we see. So let's start off with IoT, which today has become quite a kind of useless term because everything is IoT. If you go to any industry conference, every company out there is an IoT company now. So everything from home automation, sensor networks, industrial control, who's been doing networked, assembly robots for a long time, they're now IoT. They're putting their robots on the internet, what could go wrong? Agriculture, if a modern farm, if you look at like a milk farm, there are thousands of sensors doing, so that's definitely IoT. Surveillance, building management, smart cities, healthcare. So actually, if you say you're an IoT, you pretty much covered everything. You're probably working. That's probably what that means. So obviously, when we say we're an IoT company, we're not covering everything, right? So what we are focusing on sensor networks, which is a kind of a small slice. So we're not dealing with, accentuators and stuff like that. It's mainly sensor networks. And what's that then? So typically, it's kind of simple and stupid sensors who's periodically just collecting some kind of data like temperature or particle count for air quality or stuff like that. And it periodically sends this small amount of data, right? And which then accumulates in this SaaS service. And the point of the service then is kind of to store this data, like I said, and then provide some kind of tools to analyze it, to kind of mix, match it with other types of data, public, open, or private, and kind of present that in a way that is interesting, that will hopefully give you some kind of idea on the kind of problem or the concern you have. So some examples of that. So like I said, I mean, the value here is in the analysis. So some real world example from customers that we have is like city planning. So in this particular, it's cities who is expanding or rebuilding neighborhoods. So they want to think about, okay, how many parking spaces do we have to build, right? So, and how do you do that? So you can put out parking sensors in other parts of the city or similar cities and try to correlate then why certain parking spaces are full and under which conditions, and what if we put the supermarket here, how will that affect parking spaces? So trying to build up some models and comparing it to other cities was kind of what that customer was trying to do. So that you can imagine a parking sensor is a very stupid thing. A car parks and the metric is sent, and then when you gather this, you can build a model and help them to plan where and where to put the parking spaces and how many. Another thing that some customers are doing is building management. So this is, let's say I have a big business in London, a lot of office floors. The question is, do we really need this much office space? Can we get rid of 2 floors? How is actually this workplace is used? Especially companies who's kind of where people come and go and kind of open workspaces. So there it's desk sensors, meeting room sensors, and trying to build up a model on how they're used and how they can better use, and if they arrange the desk differently, does that affect usage, etc. And again, mixing data sources is really interesting. So, okay, so you have the desk sensors, but what if you compare them to like traffic outages or footfall outside the building or stuff like that, which will give you a richer idea of what's going on for your particular problem. Okay, so what kind of analysis? So that's quite interesting. So what I'm primarily talking about here is kind of the offline batch analysis. But since it's IoT and most of those devices are connected, there's also a kind of a real-time aspect. I will give some examples of that. So I want to get into this a little bit on what kind of analysis we're talking about. And also maybe a little bit, I want to try to tie it into the kind of operational problems that this kind of different kinds of analysis will give you. So real-time versus batch, and also this kind of notion of fog computing. I don't know if you heard it, where you kind of move the analysis from the cloud VMs kind of further out in the infrastructure, closer to the actual edge. I will give an example of what that could be. So we are primarily in the batch world, but we have use cases where we're more like doing more fog analysis and even edge in some cases. So what do I mean by this? So here's an example, and on the axis here is kind of what kind of response time, how quickly you need the analysis results to come back, right? From milliseconds to weeks. And on this axis is kind of where the analysis needs to happen then. And for this example, we're looking at a drone, right? A self-flying drone. I hope you're familiar with them. So for the actual kind of motor control, for the kind of tilt sensors and the sensors who's measuring how fast the rotors are spinning, we're very firmly on the device, on the edge computing, right? There's no way we can send that back home to the cloud and then send it back out. That would never work. So in the millisecond is kind of, okay, stabilizing the thing, edge computing. What about, battery levels? That is not so critical. You can set some kind of you can set some trigger levels. If I'm under 15% battery level, then okay, I need to look at the map and figure out a path to where I can land safely so I don't drop in water or something. So it's probably a bit more involved than you really want to do on the device, but it's also kind of critical, right? You don't want the drone to kind of completely go down in the Thames if the internet connection is out, right? So it's critical enough for you not to do it all the way up in the cloud. So that's something you might want to do further in the infrastructure where the actual uplink to the internet is not critical. The only thing that's critical there is the link between the device itself and the actual gateway, which we usually call it, that could do more involved calculations. So that would be kind of the focus. And then batch is kind of, looking back last week, how does it perform when it's raining versus when it's not? How many times on average do I stall or fall over and stuff like that, right? Yes, I hope you get a notion here on the kind of where this part of analysis could happen and some of the use cases. So here's another way of looking at it, Edge Pro. So one other concrete example on kind of fog computing that we have is image sensors. So you can imagine like a door into an office building where you actually, instead of having key cards, you want to kind of take a picture of the guy coming in and then kind of do some facial recognition and see, this person can come in or not. It will probably be very expensive to send all that picture information all the way up to the internet and back. So what you can do more analysis further out in the infrastructure, right? To kind of do some of the image recognition or at least some compression before you send it out for the full analysis. So that could be another example. You can kind of compress or pre-aggregate to do something clever on the edge or in the fog world that will make the world in the cloud computing easier, or you need less bandwidth to actually do the calculation in the cloud. Okay, so before we go into kind of the operational aspects of this, here is a very simple block diagram of a very high level of some of the pieces I talked about now, how like an IoT sensor service could look like. So you have the sensors, and usually those sensors are not directly on the internet. So usually they are not clever enough to run a full TCP/IP stack or whatever. So they are very simple, and they use some kind of RF protocol to talk to a gateway. And the gateway is this kind of server that's not that's not located in a data center. It's out there somewhere. It's like a deployed server somewhere. But it's still, that's the guy who actually sits on the internet, right? So it will, thousands of sensors maybe talking to that gateway, which then will collect or do some processing before it sends it back up to the message broker. There are some sensors on the internet, but mostly they are stupid enough in this to talk to the gateway. Then we have the message broker, data store, and the API, which hopefully makes sense. And the kind of analytics happens in this part, right, most of the time, at least the batch analytics. So on the API side, or you offload it into Spark cluster, whatever, and run the stuff. Okay, cool. So now, finally, to the ops bits. So what is different from web apps here? So I think the clue is in the name. So the things is the main difference. Because our customers need to deal with real things in the world, right? Usually when you do a website, the kind of browser and devices is somebody else's problem. That's abstracted away. All you have to produce is HTML and JavaScript, and then you kind of have a service. But what we need to do here, and the customer needs to do, they actually have to manage those devices. So a big part of an IoT infrastructure is the device management and lifecycle handling of these devices. You need to provision them, you have to run them and monitor them and decommission them. So that whole lifeline. And that's surprisingly difficult because devices can fail in many, many ways. And so that's kind of a big operational burden on customers deploying IoT services. It's just managing the actual hardware that's out there. Probably the biggest one. Maintenance is another thing. So a lot of these sensors are battery powered. Like I said, a lot of them fail in many different ways. So having good kind of, there's kind of two streams of data coming out of networks like this. There is one which is the actual payloads, the data you're measuring. And the other one is the kind of the operational information about these sensors, like battery levels, connectivity issues, whatever they are monitoring. So you kind of have an operational dashboard you build for people who are kind of running the sensor network. And then you have the analytics side, which is looking at the actual payloads coming in. So one example is, when you look at the life cycle of a device, if you look at the actual money expenditure, a lot of it is actually in the maintenance side because, like I said, the parking sensors that I talked about earlier, they are actually a big kind of hockey puck with a battery that you dig up the concrete and you put them in and then you fill it over with concrete again. And when that runs out of battery, guess what? You have to kind of dig a hole in the ground again, take out the puck, switch the battery and put it back again, right? And that is it is actually just as expensive just to change the batteries that to actually purchase the thing and put it into the ground the first time. So there is a lot of, so a big operational concern for these customers is actually trying to optimize the maintenance cycles. So if we have to dig up this road, can we do it in a clever way? So, instead of just doing one, can we do more of them? So there's kind of analytics going on the operational side as well. To actually optimize the maintenance cost of these installs. Connectivity, like I said, is a big thing. So sensors themselves, like I said, are typically not on the internet, but the gateways are, and how will they connect, right? How will they connect to the internet? Is cellular, Wi-Fi, which is a big problem. There are a lot of emerging radio standards here that might be of interest to you if you're in the space. There's something called LoRaWAN, which is a really cool kind of long-range, low-bandwidth radio where you can basically put one of those gateways on the top of a building and cover kilometers in a city with tens or hundred thousands of devices. It's really cool. So there's stuff like that that's real enablers for these sensor networks to really come along. Security, I left that quite late, but that's obviously a big thing. If you're monitoring sensitive data, how do you encrypt it? What about, so you have, like I said, there are multiple connections. You have the sensor connecting to the gateway and the gateway connecting to the internet, right? So you need to kind of encrypt at both levels and really think about that. there are so many examples of kind of bad IoT devices out there, you know, like baby monitors that's just straight on the internet. Anybody can just look at the baby. And I think there are indexes on the internet where, you know, hundreds of baby cameras come online every day if you want to look at people's babies. And one interesting thing here is that a lot of these sensor companies are traditionally hardware companies, right? And they are kind of ignorant to all the progress in security and encryption that kind of the software side has taken in the last 20 years. So they kind of relearning all the mistakes and doing some really horrible things. Yeah. And scale, of course. So this is interesting. So this is usually something that comes up really, or used to come up with a lot of people talking IoT. It's like, oh my God, in 2 years, they're going to be 20 trillion devices. It's like the mother of all big data problems. How are we going to do that? In reality, it hasn't really materialized yet. I think we are still on a kind of website scale of complexity. It's not worse than that. And one of the reasons where I struggle to see there will be, I don't think there will be one dominant player where all these sensors will talk to. I think it will be much more split up and partitioned. So that mediates a bit of a scaling problem. I think the scaling problem comes on the analytical side, especially if the open data comes up, where now you have all these huge data sets that you want to combine. But one thing that's really, really concrete, which comes back to the devices again, is device scaling, right? So there's one thing if you want to bring 10 sensors online, you know, on a floor, but realistically, we have customers looking to bring up to 100,000 sensors online, right? And that is already operational, really big problem, right? The whole life cycle of those 100,000 devices, and you're managing them and monitoring them and replacing batteries, that's a real issue, even at 100,000, which might not sound like a big number, but it really is. Okay, more concerns with the edge, and so that I'm mainly talking about the cloud side when you do batch analysis on the cloud. So super simple sensors, a little gateway, and then you do all the smarts on the cloud. If you don't do that, you have more problems. If you're in the kind of edge world, now you probably have a much more sophisticated thing. So you want to update the software in that much more often, right? So now you have the whole over-the-air update problem. You have to now really monitor what version of software all these devices are running. You have to have ways of upgrading the firmware. And some devices are 2 versions behind. You have to cycle them through all the versions so you can bump them straight up to the latest. You have all these. You have the remote bricking, which is a big problem now. So to have, how do we roll back OTAs that went bad? Another thing that makes this extra hard is that most of those devices are not on the internet all the time. Like they wake up once an hour for 5 minutes, and then you have to do everything. Otherwise, they run out of battery, right? So how do you do OTA in that scenario is quite tricky. If you're more in the fog world, so you're updating software not in your data center, but basically, so a gateway is basically like a Linux server, but it's deployed like in the infrastructure. So it's harder to do upgrades than in the data center, but it's definitely better than the edge case because it's more like a server, where a device is probably something completely different. Okay. So that concludes like the part on some of the architectural challenges and operational challenges that these IoT companies face. Now a little bit more about the experience report on how we've been doing OpenSensors, and I will not keep you for too long. So we're a startup. We have kind of the typical startup journey. I don't know how many of you have experience working in startups. But typically how it goes is you start up, everything is great, and the developers just hack away on an MVP, right? So anything goes, all the shortcuts, we just do it and to kind of prove the business idea. So that's exactly what we did. So totally focus on innovations, screw ops, screw everything. We have to get something out there. And what happens then? So either the startup dies, and then that's fine, or we start signing up customers and start getting traffic, and then, yeah, it's not great that our message broker is falling over every 5 minutes or running out of memory, right? So now you're kind of, now you're kind of victim of your own success. So how do we turn this MVP into something that we can actually run and sell to customers with a straight face? So we kind of went through all this. So the situation you're in is like, okay, first of all, we have to kind of apply some standard DevOps to our kind of handcrafted thing to actually kind of automate some steps, get the database. Maybe we shouldn't run the databases and the web server on the same VM. Stuff like rudimental things like that developers do. So we have to, at the same time as we're splitting this thing apart and kind of applying some automation, we also have to rewrite everything at the same time, because it's all, all the shortcuts and stuff we have to do. So that's kind of a phase we went through. It's hard to, I can only speak generally about that, but it's like you do one thing at a time, and most important thing first kind of approach. And there you can kind of needle your way through that journey if you're kind of careful. And at the same time, the team is small, so you need a team where everybody can do everything basically. So it's quite important. So we went through that journey, and here are some things we found. So one of the things is the whole microservice thing, right? So when you're a startup, you really don't have a lot of money at hand. So going full microservice, we couldn't afford. Because what are the problems with going full microservice is, okay, each microservice needs its own database. You need message buses. You need a lot of monitoring. You need probably a lot more VMs. And all those adds up. And saving 10 grand here and 10 grand there over the year in ops is really useful for a startup. But then again, we can't have this big monolith where everything is happening. So it's trying to find finding the right approach of breaking it about not to microservices as is, but small enough services so we can deploy it and operate it, with some kind of sane way. So we don't want one database per service. We don't really want the message bus either, because it's just too much ops, and we found an internal REST architecture to be simpler to understand, simpler to monitor, and also we wanted to minimize the different pieces of infrastructure we needed to run the entire service. So we don't want an extra service discovery thing. That was just too hard. So console was out, right? No, we already spent our DevOps budget. We can't deal with that as well. So keep it really simple, and keeping it eternal REST is our approach. Sure, a familiar approach to many of you who's been thinking about this a long time. Another benefit is actually of not going fully microservice is if you clump it, when it's a little bit bigger, a lot of the things that would include communication between microservices is a lot simpler, because everything is kind of in process, right? You can just call out, you can share memory. If it was fully microserviced, you have to really, from an architectural level, deal with, okay, when we do these operations, we are triggering all these 5 microservices are part of it, and what happens if that is down, or that serialization is wrong, and the complexity matrix explodes. And if you're in a startup situation, it's probably not worth to pay that. If you scale enormously, there's a different equation, but in a startup scenario, I think it's important to not just, everybody's doing microservices, let's do it. Actually, think about it a bit. It's all about kind of spending the cycles correctly here, and not go crazy and split it up too much. We found that quite beneficial to break it apart in a few pieces, but not too many. Another problem we did was we had many loops kind of failing with our data stores. So one key thing here, if you remember the architecture, is kind of storing all these metrics, which is kind of like a big table, Dynamo, Cassandra kind of problem. And we did all the classical problems here. We kind of picked a data store based on the kind of queries we wanted to run, completely ignoring the kind of ops aspect of it. So bringing up the cluster, maintaining the cluster, operating the cluster, right? And then, of course, 2 months in, when you actually start running traffic through the thing, or maybe not traffic, but actually running it for a while, a lot of the ops issues kind of bubble up, and then you're stuck in this firefighting mode. Another thing is, which is maybe a bit unique to IoT, is kind of the usage patterns. So the top graph here is typically how, I kind of left the scales out here, but imagine this is the total number of kind of publish messages coming into our message broker, right, that we need to store. And there's a very strong level of periodicity in this. Because you can imagine these sensors who's online just 5 minutes per hour, they kind of run like cron jobs. So they wake up every hour on the hour, take a sampling and send it. So you have this big cascade every hour or every quarter of the hour with a lot of sensors coming online, sending the data, and then goes down again. So you in the extreme, you kind of need an infrastructure that is kind of fine-grained enough to kind of, okay, because you can predict this so well that you kind of scale up the data store, whatever, Dynamo or something, turn it up a little bit, just on the hour, and then you can turn it down again. So you can really optimize that if you want to. Or you have queues in front or whatever, depending on what you want. But this is quite, maybe unique for IoT, I'm not sure. But it's very, very strong. So one thing we kind of combat that, or try to combat that, is that we take more control of what happens in the gateways on the devices. So you would have like an OpenSensors SDK, and for the cron sensors, we will build in some randomness, so they don't all of them are waking up on the hour exactly. So some of them are kind of spread over the time spectrum. For reads is typically kind of somebody's triggering a run to run a report, and usually that's manually triggered. So some analysis, or somebody's interested in running a report for this office building. They press a button, and then it triggers a huge load of data from our service, and then they go into their models, however it goes into Excel or model, however they do it to generate the report, which leaves the extremely spiky kind of read patterns. It can be quiet for hours and hours, and kadoom comes a giant spike because somebody pressed the button. So dealing with that is, as you can imagine, quite hard. Yeah, okay. Not much to say. Hosted services is amazing. I know this is old news for all of you, but it really helps us as a startup. We have a very tight DevOps budget, and if we can use hosted services, fantastic. So whoever came up with that, amazing. It's the best thing ever. Yeah, I've been giving the sign here, so I will just say thank you and see if there's any questions.